Hello, everyone. My name is Bruno Denis, and I will present today generative AI models for data science for insurers. So I've been working very actively at Microsoft, now at Avanade, which is a joint venture between Accenture and Microsoft. So my aim today is giving you some updates on generative AI in a context of insurance practices. So what we will cover in this capsule is what is generative AI, why generative AI slash large language model for insurance company, what are the challenges that we face, but also what are the key opportunities. So first, let's look into generative AI. It's a buzzword that's been used by everyone across the board, sometimes not very precisely. So I want to just refocus on what is really generative AI. So generative AI is a subset of machine learning, which is a subset of artificial intelligence. Okay, so GenAI creates new data, while in the past, artificial intelligence was able to act on data following preset rules using algorithms. Or using machine learning, where machine learning would learn how to act from the data it was presented to. Generative AI is different in the sense that it will generate output based on a query, based on a huge corpus of information. And so it's, in that sense, very revolutionary as you can use natural language to query gigantic corpus of data made available through the platform. So another point that I want to touch base is the difference between generative AI and artificial general intelligence. So we have been discussing a lot about how computer could really work as real humans. So will be always on activated, listening to you and being able to interact with you, as you might have seen, for instance, in Interstellar film. So we are very far away still from artificial general intelligence, even though all the large tech companies like Google, Microsoft, and others are interested to go in this direction. So generative AI and large language model are a first step into this direction. Another key differentiator between generative AI and artificial general intelligence is the fact that there is no real cognition within a generative AI context. So it will just take your query, slice and dice your query in different tokens, and make sure that the output is the most suitable from a statistical standpoint, based on the data it has been trained on. So there is no real human-like cognition. All human-like cognition is instantaneous, and it's based on our beliefs, on our sensation, on a lot of different elements than only pure data facts. So human-like cognition is even more complex, as it incorporates sensory information which are far richer than what we have only with LLM system today. Another key difference is that the generative AI is mainly generating content based on pre-existing data. So it will potentially be reinforced a bit by some input that you might give as a user of it, but it's not interacting and learning from the different permanent interaction that is got with its users. So those are the three main elements of differentiation between generative AI and artificial general intelligence. So what is the path that that we could imagine towards artificial general intelligence. So today we have already GenAI chatbots. We have the existing OpenAI, Grok AI, Mistral, you name them. So there is already an interface allowing you to ask questions in natural language, in different language, in nearly all the language of the world, still based on this huge corpus of data. So we could call it as a generative AI chatbot, let's say. That's what we have today. Then the idea in 5 years from now, so from 2024 to 2029 or 2030, the idea is to go to unsupervised reasoners. In 10 years from now, we'll go into unsupervised popping up agents with creative reasoning. And then we might go in 20 years to go into a full AGI solution that would be included in human organization, where we would be actively interacting on a permanent basis with a superior cognition that would be present there at all time and support us. So that's a bit what is in front of us to get to artificial general intelligence. Now, so I won't go into all details, but very high level. How are GenAI models being built? They are built by using vectors of tokens. Vector of tokens are called embeddings. So any kind of object that you have, it could be an image, a text, a music file, anything. It could be a CT scan in a medical world. It could be a photo of an accident that you need to inspect, for instance, as an inspector in an insurance company. Those objects will be going through specific transformers that will allow to create a specific vector of tokens. So their task would be to be able to do object recognition on an image, for instance, translation of texts, anomaly detection in music files, or speech to text, for instance. So large language model, how I see them is that they are using different key building blocks. And that's important to understand those 5 key building blocks. I call them pata, like a pole in French. So you have the tokens. So tokenization is an important element of a large language model. Embeddings, which are vectors of tokens. Transfer learning, so the way that you would be transferring a learning from one set of query to another one, the attention mechanism that you have as well, and the pre-training of the existing corpus of data. Those 5 elements are very important, and they are interlinked together to be able to create what we call a large language model. First, let's focus on tokenization. What is a token? A token can be a token in a word context. So it could be just slicing and dicing a phrase, a sentence. It can be image tokens. So the image token will look at different pixels in the data and would create tokens based on an image which is presented to it. Video, same thing. You can have iterative co-tokenization systems. Speech, same thing. You have speech synthesis by learning monotony algorithms and alignments. So there is different methods to create those tokens, but the base and what is important is understanding that tokens are there and are the base elements on which LLM system are working. Embeddings are the vectors which are a mathematical representation of the data, of different data. So here you have an example. You have it's in a words format. So you have man, woman, king, queen, and you need to determine whether you have links between those different words, okay, related to different parameters that you determine, like life being, feline, human, gender, royalty, verb, plural. So all those parameters, so you will have a probabilistic view on whether this word refers to the specific parameters. Is a man a living being? Yeah, probably yes, 60% of positive value. Is a man a felon? No, minus 0.2%. Is a man a human? 0.8%. Is the word man referring to a potential gender? 0.9%. So you see, you can really make, for each of those words, you will define a specific vector. The embeddings is the representation of the data, as I said, and the distance captured between the different data sets. So you can see that women and men here are closer to each other than king and queen. So that allows to create those embeddings and to create the relationship between those different tokens. Transfer learning is also an important element of LLMs. So you have traditional ML that work based on each specific data set. So you use one data set and you apply learning methodology, learning task on these data sets. On transfer learning, you will create a knowledge base based on what you already did on the data set one that you might reapply on data set two. So this transfer learning capability is a very important element of the large language models. In large language models, you have also the concept of attention, which gives the ability to be self-aware, self-attent, to be able to represent and be aware of the contents for each element that you have in the sequence. So this multi-headed self-attention allows the model to learn the different aspects of the relationship between the elements. So this leads to more robustness in the way that the model is performing afterwards. And last but not least, pre-training. So all those LLMs today are based on massive corpus of data of pre-training using modern deep learning technologies. And this is what makes a huge difference in terms of being able to be exact as an output to a specific query. The LLMs are mainly today still pre-trained, so it's a massive pre-training capability, function that needs to be realized, and which use phenomenal compute and storage in the cloud to make it happen. So it lasts for weeks and even months to be able to compute all those information and create the model, create the deep learning model and the associated graph. So now let's speak about insurance professionals and GenAI. So how would we use generative AI and large language model in an insurance context? I think this is a very key question and very important, as insurers are mainly, um, it's an activity which is mainly based on pure gray matter, let's say. So it's just administrative tasks which are being done. There is no real materiality in any of the process. It's really based on on business processes from A to Z. Um, Sometimes you might have some materiality in the sense that you need to do inspection of vehicles or things like that. So you might have some movement, but at the end of the day, it's an industry which is based purely on um, data and information processes. So there is a lot of attention into it because we know that there is a lot of possibility to do automation of business process within the insurance domain. So it can be, for instance, formal assessment of potential use case, how AI and ethics are being developed. Is there so we see that within the insurance domain there is a lot of attention into that. So a lot of people are working days in and days out to determine what are the best potential use case. So in practice, how we can see the overall model for a multi-model self-supervised training in insurance is you have within an insurance context, you can have text, contracts, any data related to the injury. You can have inspection details. You can have actuarial data. And you can have audio file as well if you have got a contact center service and that you record some information. So all those elements will be used to create what we call the general multimodal AI. You could have images and video of asset, accidents, claims, you name them. You can have real world evidence as well from a health data standpoint if you are into life insurance. So all those elements which are coming from the past, historical data, but also real world data coming from other source might be used. The same with signals, alarm sensor. Let's say that you do that you offer an insurance against thefts. You might want also to have a view on the signals coming from the cameras or from the house that you try to protect. And then you have an historical view on the underwriting data and the way that the police has been evolved in the past based on the risk factor that you consider for a specific police or a specific group of people. And last but not least, all regulation, compliance, good practice that you use within the insurance domain. So all these elements, can be fed into a large language model, a specific large language model that would be used by you as an insurer. You could add legal and regulatory corpus, actuarial corpus, inspection notes, knowledge graph. So there is billions of data points that you could add, and then you would be able, as a company, to interact to this large language model of your own, and do prompting and querying, not only using public data, but using the very specific data that you have created over time. And that's where the magic is coming, is that you create then your own multimodal trained data sets on which you can query and help yourself to automate some of your internal processes. So I've been working in different on different GenAI GenAI projects very recently, and there is to me and to different people working with me, there is a kind of pyramid view of value and feasibility of some of the use cases in the insurance domain. What I see is that, for instance, there's a high value in automating case management based on online or face-to-face meeting between agents and insureds and insurees. So if you have the ability to record some of the conversation you have with your clients, with their with their acceptance, of course, then you might get some very interesting data analytics out of it that you could use for other purpose. Same thing on the value that you could have by having an automated collection process for life or disability of people that you insure, also based on some proof, on some consent, obviously, and countersigned by medical professional. That would also be a high value that you have to have a better understanding of the type of risk that you have in front of you or forecasted risk that you have for life insurance. So I will not go into all details of those use cases, but there is many use cases where generative AI can be used in an insurance context. Also, GenAI offers you the speed that you do not have if you do not use it. So if you need to recover data in a non-GenAI context, it will be far more complex. You will have to search for it manually. It will be more difficult to retrieve the exact information or to correlate different sets of data. There is also no code if you use natural language process. There is no extra code that you need to build. You just query natural language, which is extremely easy and allows you to spend less in pure development purpose. It will cover also 360% of the insurance process, from products, marketing, underwriting of new police or revision of existing police, claim management, so any kind of activities that you might have within the insurance company could be covered by generative AI solution. The LLMs would be trained on insurance-related data points, so that's will bring an extra value. And there is, if you look at open public LLMs today, there is already data source like ESMA codes, real-world claims data, georisk, weather data, EMA, FDA registry, satellite imagery, criminality records in different countries. So there is already a lot of public corpus available, which can ease your day-to-day activity. So if you look at the overall different business process within an insurer, from, as I said, product development to policy renewals, comparison, risk, predictive analytics, customer service underwriting, claims, frauds, risk management, you have a full 360 view. So it can really drive your innovation in the future and automate some of the lengthy process that you might have. For instance, if we use policy comparison using OpenAI Enterprise, so the Copilot Enterprise of Microsoft, here I'm just wanting to compare it very easily, the different type of hospitalization service which are available to me in Belgium, in the main insurance company, looking at AXA, Balois, Zurich, AG, Assurance Fédérale, and any other, then I would have a direct view on what is covered in a very easy way. So it will ease my comparison. It will also ease the comparison between the different companies to make sure that you are always up to date with the latest information available on the policies of your competitors. So that's already a very interesting feature. It can be done in 30 seconds and give you a lot of extra information. On customer service as well, you can have a lot of new query capabilities based on applications like Future Insurance, for instance, that would allow you to have claim assistance. So you could really have NLP-based chatbots that would directly guide you through the claim process. That's something which is powerful as well and allow for a good customer service and a good interaction and a feeling by the client that is well served, even though there is no human available yet. So that can be used in the front end and then be potentially also reinforced by a live agent. Another very important element in the future is having really synthetic call agent through video. So you could use WhatsApp, any kind of interface where you would interact with
Hi,
an
I'm
agent
Bowie, and I'm here to
that
help.
would speak to you
Please note that I am an AI-powered
and just
synthetic human
interact
and not a real person.
in a natural way.
Nevertheless, I am happy to support you with
To report a damage on my car.
And you could speak
I'm all
into
fine,
it.
and I was wondering if you could help
Here,
me?
it's an example of where someone will just ask
Hello.
and say that he had
I'm
an
glad to hear
accident.
that you're okay. I can
So
definitely help
here
you with that.
Bowie is giving
Can you please
as
provide me
a
with your
full
name,
script available,
surname, and date
but
of
more
birth?
than a script, she would really
Sure. My name is John
be
Meyer,
able
born
to
on December 10th,
answer
1998.
and guide the client into the claim
Thank
process.
you, John.
You could also use it for false claim detection, where you could post a picture and analyze whether the picture that has been provided as a proof of an accident is really aligned with the explanation that the holder of the car had. So here I was just checked on whether I could use a specific picture and compare it to what the people said, saying, "Oh, you have a blue car here," and the blue car said, "Yeah, he bumped into me by the rear," while the gray car said, "No, no, no, no. The blue car bumped into me." Um, Bumped into me in rear, so in rear speed. So that's a way to interact with the visual data and being able to detect some potential false claim. So no, so you see there is a lot of features, a lot of capabilities, which is very nice for an insurance company, but there is obviously always challenges. And those challenges are important to understand. In generative AI context, obviously, depending on the richness of the data that you have and the availability to retrieve this data, you might have limited traceability. So you might interact with the system. It will give you an answer, but it will not give you access to all the data sources, because it's a combination of private data source of your company plus public data. So it's becoming extremely complex to create this access to this to all the metadata. You also have irreproducibility of the prompt. So you might ask exactly the same question. What is a cat, for instance, in my example here, and you will have always different answers. Same prompts, different answers. So that's a challenge if you want to answer, for instance, if you have query related to critical health questions, for instance, if you're a life insurer. I also, another challenge is the adherence to fair data principle. FAIR is a common model for any kind of technology vendor using artificial intelligence, like Microsoft and OpenAI, Gemini of Google, Mistral AI, Grok from X. The idea is that there should be fairness in the way that the algorithm is working. So the output of the prompt is returning information to the users. So an easy example is an example of that I often explain. So it's someone coming to the cockpit of a plane. So a steward coming to the cockpit of a plane and just dropping some coffee on the floor close to the pilots. Then I will ask the GenAI to provide me the rest of the storyline and say, okay, so there is a steward that came to the cockpit and dropped some coffee on the floor close to the pilot. Can you give me a bit more information about the pilot and the steward? Who are they? In the majority of the case, they will always say that the pilot is a man, and the steward and stewardess would be mainly a female person. So there is an inherent bias linked to the fact that the representation of the world is like that. So in a sense, the model is doing an exact job from a probabilistic standpoint. There is more pilots, male pilots in the world than female pilots, but it still will answer using he instead of she. So the way to counteract this is making sure that there is a way to tune to limit this inherent bias. It's what OpenAI is trying to do, but it's not perfect yet. Another element is the accountability. There is no accountability of the LLM development team on output from the LLMs. There is also a challenge related to transparency. There is no full transparency in the way LLM generates its answers, nor access to all metadata that is using to generate these outputs. Is it private? Yes, it's partially true if you use your own RAG model, so your own GenAI model, but it will not be true if you are not using enterprise-grade services where your private data might be exposed to an external, engine that would create the GenAI graph. And then robustness. Is it robust? Partially true. So there is robustness as you increase the size of the parameters used by the LLM, but at the same time, the output that you would get might not be always as robust as it is if you ask very specific questions. So in a nutshell, there is still a lot of work to be done to make sure that those generative AI systems adhere to fair data principles. Another key challenge is hallucinations. GenAI are trained to fill the semantic gap, meaning that if LLM does not have a clue about a specific answer, has no access to specific data to it, it will bridge the semantic gap. So it will respond to the prompt in any way or another to make sure that the answer seems the most probable as possible. Meaning it can be the most probable, but it might be untrue. So they will create this synthetic data, even if inexact, to fill the semantic gap, to offer what can be perceived by you as human as a complete semantic answer. So, having looked at the positive sides of generative AI to transform your insurance companies and transform your daily practice, and having looked at hallucinations and also challenges that you might face, I'm always looking more at the positive sides of things. So I think that it will obviously be there and bring a lot of potential for automation based on what you are doing today. So if you use GenAI to automate your insurance process, in the majority of the case, looking at all literature on the matter coming from all consultancy and technology firms, you might get on product management, around 15% of process improvements. Same on the customer service side, 25% process improvement and higher customer satisfaction, faster interaction with your clients, faster response to their queries. In underwriting, same thing. You might also ameliorate your model using GenAI and being able to fine-tune it even more for specific policy definition or new type of risk that you want to cover. Claim management, very important. You can really automate further this claim management process, which is very key in your domain to make sure that you can retain your clients. So all those elements of process automation are very transformational, and you will be confronted to it now and in the future. So the key question is, what do you believe the future of insurance will bring using this technology? What is the shape that your company will have in the next future? How will you interact with your clients? And what are the business model that you want to apply to be successful? I leave you up to these questions. So I was glad to present this, and do not hesitate to contact me if you have any question and would like to discuss the future of insurers with generative AI. Thank you.